At this point, I assume that you have been following us and taking time to understand all the concepts around finding the mean, mode, median for the various data types, and also you have understood the basic terms that you'll be using for data type 3. Let's jump into doing finding the mean of data type 3. Now we are ready to begin to use the tool, as I said in the previous session. So now that we are now ready with all the terms together, let's see how to find the mean of data type 3. And since it's a big deal for WASI, for WAEC to be setting questions around that area, let's see what goes into finding the mean, mode, median respectfully. So this time we are going to focus on mean for the first. So let's see how we can do that. So I will give there is some example that have here. A class against frequency. We have explained a lot of terms around that. So now, how do we find the mean of this data type 3? We know the characteristics, right? And I assume that you have watched, so you understand why this is data type 3. So yes, data type 3. This is data type 3. How do we find the mean of data type 3? We are dealing with class. Unlike data type 1 and 2, we're looking at the individual items themselves, right? We are looking at the individual items themselves. But here we are dealing with a class of them. Like for example, the 40 to 49. All numbers that fall within 40 to 49 in the data set, they all count up to 12. That's the frequency, 12. So 40 to 49, right? Within 40 to 49, there are 12 items that we found there. It doesn't mean that between 40 to 49, all the individual every number is represented in the counted items. For example, 40 to 49, we can have 41, 41, 41, 41, 43, 44, 41, 41, 40. You see that not all the numbers are represented there. So if you want to just find the mean, and we said the mean is basically what? You remember is sigma fx over sigma f. So that's what we found for the mean from the previous session. But how we don't have x here like this, right? We have a class of items. So the frequency, our frequency is f. Sorry, it shouldn't be x. It shouldn't be x. It should be f. Let me just replace that for you. Yeah. So these are the counts f, right? So how do we now do the fx in this case, sigma fx? So let me write the general form of the mean. Mean is equal to sigma fx over sigma f. But then how do we get the sigma f and the next? So which one is the class to the x here? And if it's the x, which number are you going to multiply by the highest and lowest? No. What we are going to do is that we are going to use the class midpoint. So between 40 to 49, we are going to look at the middle items. The middle item, that's the class midpoint. We learn how to evaluate that in the previous session, right? So class midpoint is just the sum of the upper limit and lower limit divided by 2. Basically, we are actually finding the mean of those two numbers, right? 40 and 49. You put them together, you're trying to find the middle point. So we need another session here that you have to open another column, and then for each class we are going to find midpoint, class midpoint. Yeah, so you can write that in full. So this one will be our single item x now, because it's not going to be in a range. Because we need something like that, fx. So we don't need a range of items, but instead of we don't know which of them to use. So the easiest thing is to find the sigma fx. So the middle point of this 40 plus 49 divided by 2, we are going to get 44.5. The same thing goes to the next class, 55.5. Then you have 65.5, 70 plus. So we have 75.5. This one will give you 85.5. You have to actually be doing the calculation. So 95.5. That's the last one. So these are our midpoints. Okay, and then we say this midpoint is just like we are finding the mean of the upper limit and lower limit divided by 2. 40 plus 49 divided by 2. 50 plus 59 divided by 2. Yes, now we have fx. Does it mean that we are ready now to do the fx now? So we can just multiply the frequency times this x now. So that x is the midpoint. But see, the problem is all these items, right? We are not all, because all elements are not representative of each other and they are connected, right? 40 to 49, not all the items therefore within 40 to 49 are represented by the count 12. So there is one more thing that we need to do to make sure that we arrive at the actual answer, right? We are going to call that mean deviation. So we are going to have a mean deviation. We need another column for that. The reason why we are doing that, that's what I'm explaining, right? So this one is mean. So yeah, let's call it deviation. Yes, so that I can be able to write uh, my column. So now mean deviation. How does this is this one done? So because it's data type 3, right? We are going to have an assume mean. We are going to assume a mean. So assume mean. We need an assume mean from which all these means, right, deviate from. So individually they are like mean. 40 plus 40 divided by 2, something like that. I said it's just like mean. So all these things are like mean, right? But we need an assume mean from that. We need to assume a mean at the beginning. So data type 3 usually if you want to find the mean for data type 3, you need to have an assume mean. The question will give it to you, or if they don't give it to you, there's a way to find it, and which I'm going to show you right now how to easily find that when the question doesn't give it to you. Or if the question give it to you, compare and see. Now, after you find your class midpoint, the next thing is to find the deviation, because you are going to find one mean, assume one mean, and see how the other mean deviates from that. Because we are looking at a range of items, a range of classes, a range of numbers instead of the items themselves in data type 1, data type 2. So if we are going to assume that this is our mean and see how the others deviate from that particular mean that we have assumed. So in doing that, we are kind of pulling them together and trying to make sure that we arrive at the rightful mean, right? So we need an assume mean, and the assume mean shouldn't come outside, or it shouldn't fall outside the range. The assume mean should fall within the range. The mean should come from within the range of the items. So we are talking of 40 to 49 up to 90 to 99. Then you are bringing an assume mean of 100, an assume mean of 150, or an assume mean of 20, and an assume mean of 10, right? It doesn't work like that. The assume mean should fall within this, especially within the class midpoint, right? So we need to have an assuming. The question will give you that. But then if the question doesn't give us, in this case the question didn't give us, right? How do we find the assuming ourselves? So you need to have an assuming from which the others deviate from. Okay, so now to find the assuming, what we do is that you're going to still use your finger method, right? So what we do is that you count from the top and the bottom, from the end. One hand at the top, one hand at the bottom, right? So one hand at the top here, one hand in the middle. So there we are here now. Then the next you move inside to get to the middle, from the top to the middle, right? So now this one goes in, so this one comes like this. So this we also circle this. We are trying to get towards the middle, right? Now when we get towards the middle, if you move this and move again, there's nothing. So if you move like this and you move like this again, nothing is going to be left in the middle, right? It's just like how you are finding the median and that we did for the type 2 or the type 1. So let me quickly put that in order. So at the end there are two items in the middle. There are, so this guy moved, right? So this guy is still here, but this guy was not here. Yeah. So yeah, so here we have two items in the middle. So we move from the top, one hand at the bottom, one hand at the, then we're moving towards the middle value, the middle value. So we go like, okay, when we go to the middle, there are two items, 65 and 75.5, 65.5 and 75.5. One of these should be the mean. In a case where you have two items in the middle, pick the smallest number as you're assuming. If there's only one item, then that one item is it. That is it. But if there are two items in the middle, just pick one item. So in this case, our assuming is going to be the 65.5. So our assuming is going to be 65.5. That's the mean that we are going to assume, right? That's how to find your assuming if the question doesn't give it to you. If the question give it to you, to just go ahead and do that, because if they give you an assuming, there's nothing you have to do. The main thing, I understand why we are doing the assuming. That's the most important thing. Because we need to find a mean, because it's a range of classes, right? Not all the numbers are represented. We just counted the number of 10 that fall within ranges, but not every individual item. To find the mean, after finding the class midpoints, we use one of them as the assuming, then we find the deviation of the others around that assuming, right? How do we now do the deviation? So deviation is your x minus the assuming a. So I'm going to do that a. So assuming is going to my a, assume, a for assume. So the s minus a all the time. So s minus a all the time, my x is what? In this case is 44.5. 44.5 minus a. My a is 65. So let me just use my calculator. 44.5 minus my assuming is 65.5. So I have negative 21. Negative 21. Then what do I have again? 51, right? So let me see. 54, 55.5. This one, are they 65 or no? 50 plus this thing should be, oh, they should be 54, right? 54, 64, 74, 84, 94. So if you just do the assuming, right? So yeah, correct that. I know some of you have corrected that. So if you do the calculation, right? So that's why it's very important to use your calculator alongside, right? 44.5. So 40 plus 49 divided by 2 will give you this, and that's going. So now the next one should be 54. So let me clean that. 54. I have negative 11, negative 11. Then I go again. I think it's 64 now. Negative 1, 64 minus. So my assuming will be 64, 64.5. So I think I need to just correct the first one. Yeah, so I need to just correct the first one. 44 minus 64.5. So the first one is actually negative 20. This one negative 10. This one 64.5 minus this one is 0. So the assuming itself will turn 0 at the end of the day. Then you have 10. Then you have 20. Then you have 30. This is what we have for the deviation. So this is what we have for the deviation. So now the deviation, let's call it d, right? Now we haven't done this. We are looking for sigma f first times sigma this, right? So now what we are now going to is the d has been, d is the one that we are going to use as our x for the type 3, right? Instead of using x, we are going to use it because now we have to remove some things, right? Do the deviation. So the deviation is what we use. So we are going to call this fd. So it's going to, our f is 12, right? 12 times 20, as I think is let me use the calculator to do this. 12 times 20, negative 240, negative 240, to be on a safer side, yes. So this one is negative 180, and then this one's let's say 11 times 0 is 0, right? And then 7 times 10 is 70. 50 times 20, that's 5 times 20, sorry, that's 100. 4 times 30, that's also 120. Now we need to find, so this bottom is going to be sigma fd. So the sum of all this is just like, now so our mean is equal to sigma ft all over sigma f. So now we need to find the sigma f. Sigma means the sum, right? So we need to sum all this fd. So I'm going to negative 240 minus 180 plus 0 plus 70 plus 100 plus 120. What I have here is negative 130, negative 130. That's what I have for my sigma fd. Negative, so sigma fd is negative 130, right? Over sigma f, so I got the sum of all frequencies. Then it is still the sum of all f. That's sigma f. That's what we have here. So I have 57. But wait, if you go like this, right, we are going to mix up something. So the sigma f, if you look at what we have, right, we have eliminated this mean from the entire thing. The one we assume, right, did not count in the whole of sigma fd is 0, right? Because it is our assuming. So it's the one that we've subtracted everyone, we started from everyone to see how they approach that. What will happen is that at the end of the day, we need to account for the total mean, right? We have the assuming, and then this is the mean that we got from the, it's as if we have ignored this assumed mean in the calculation and done the sigma fd for the rest. At the end of the day, what you have to do is that you must make sure you account for that one that you remove from each of them. So how do we get that? So the mean, the total mean, actually the mean is, it should be assumed mean plus sigma fd all over sigma f. This is the general formula for data type 3. I didn't want to give you at the beginning because I want you to follow me and understand how it's done and why we get that. So the assuming comes back because we need to account for it, and then in the addition, it was not the assumed side has been what ignored in doing the sigma fd over sigma f. So at the end of the day, we need to add that. It's as if there are two means. This is the assuming, and then this is our calculated mean, right, from sigma fd, and then this one did not contain this, so we need to just add this. So at the end of the day, we had so negative 130 over 57. What do we have there? So 130 divided by 57. So I have something like 2.28, right? So negative 2.28. So if I add the assuming is 64.5. Remember, we corrected that, plus negative 2.28. So it's going to have 64.5 minus the answer that we got. So now we have 62.22. This is our mean. This is our mean. Someone will say the unit. Or if there is unit there, you add it. But in this case, I didn't add any unit in the frequency or whatever. So you are safe. So this is our mean. This is the mean for this data type 3, right? If something is not clear, just go back and rewatch on hear what I said again at a point. The reason why we bring back the assume mean, because assume mean was not accounted or was not included in finding the sigma fd over sigma f. So when we are done, because it's assuming every other data or every other class midpoint has been worked, have been evaluated around that by doing through subtraction, you need to make sure you bring it back. So your actual mean for the distance, actual mean is equal to assumed mean plus calculated mean. So your calculated mean is the sigma fd over sigma f. And then note that in sigma fd doesn't contain your mean, your assumed mean. So when you are done calculating that part, then you come and add your assumed mean. Basically, this is the general formula. You don't have to choose the formula, understand what is going on and understand why each column is needed in evaluating the mean, right? And I understand why because we are dealing with a range now, and not every individual items are represented in the data set. So you need to make sure that we do an extra work by making sure that we arrive at the correct answer. So we have to find an assumed mean from the data set, and then make sure that the others are worked around by through subtraction. Then when we are done using the sigma fd over sigma f, which is the same as what we did in sigma in data type 2, we just added the assumed mean at the end of the day. So the general formula for mean is sigma fs over sigma f, but for data type 3 is assumed mean plus the calculated mean, and the calculated mean is the sigma fd over sigma f. And we saw how to find the assumed mean as well. So in future we'll do examples to actually show you how it is done more. Do the practice, or we try to look through the practice question and see how they work around that. Try this process, this understanding, and see how this thing work down. Next time we are going to see another example so that we can solidify this concept, and before we move to finding the mode. We need to take time on the data type 3 because that's a very important concept and thing that comes in WASI. See you in the next video.